A very good day to all of you. Today we are going to learn the triple integral in cylindrical coordinates. Okay, so this is a x, y, z, okay, axis, and the r, okay, as you learn in polar coordinate, r squared is actually the x squared plus y squared, and this is a theta, okay, make between the r and the x-axis, and this is a z, the vertical, okay, distance is z. Cylindrical coordinate, we have the r theta z, the r theta z, where okay, the triple integral in cylindrical coordinate, okay, in Cartesian scale, we have the triple integral f x y z dv over the solid g, where the dv is actually, if your solid g is parallel with z axis, we integrate respect to z first, dz, and then the dA. Where in polar coordinate, you have learned, okay, dA is actually the r, the theta. When you have learned in polar coordinate, dA is actually your r, the theta. Where the x is actually r cos theta, y is actually r sin theta, z is z. In cylindrical coordinate is actually 3 dimensions of polar coordinate by maintaining the z variable. However, x change to r cos theta, y change to r sin theta. And again, okay, if we integrate respect to z, okay, this is a lower surface will be lower limit of z, upper surface will be the upper limit of z, okay, z. And r, this is a lower limit of r up to upper limit of r, and theta from the lower limit of theta up to the upper limit of theta. Okay, for example, okay, we have this solid G here, where the lower surface is z equal to g1 r theta. So this will be a lower limit of a z, and this will be the upper limit of the z, which is equal to g2 r theta. Okay, and then okay, let's say this is a region r, and the r is bounded. Okay, lower limit is h1 theta up to h2 theta, and theta here, okay, here you can see up to from alpha to theta. Okay, and this is a conversion formula from rectangular to cylindrical coordinates. As I mentioned just now, x is equal to r cos theta, y is r sin theta, z equal to z, r squared is x squared plus y squared, tangent theta is y over x. Okay, for example 1, finds the volume of a solid G enclosed between the cylinder x squared plus y squared equal to 9. So this will be, you have the r squared equal to 9, okay, or r equal to 3, and the plane z equal to 1 and x plus z equal to 5. Okay, let's look at the solid G here. If actually the cylinder cylinder r equal to 3, because from x squared plus y squared equal to 9, r will be equal to 3. The plane z equal to 1 is actually the bottom surface. Okay, from the plane x plus z equal to 5, this one, okay, turns out z is 5 minus x, because the cylinder x squared plus y squared without the variable z, which is parallel with z axis. So your solid, okay, is actually the cylinder with radius 3 units centered at the origin and parallel with z axis, and the cylinder is, okay, bounded by the bottom surface z equal to 1 and upper surface x plus z equal to 5. Hence, okay, normally if your solid is bounded by cylinder, okay, or sphere or hemisphere or paraboloid, where you have the term x squared plus y squared can be substitute equal to r squared, then you can use the cylindrical coordinates. So in this case, okay, the volume is given by triple integral dv, and okay, the cylinder is parallel with z-axis, so we integrate respect to z first, and the dA, because okay, the projection of the cylinder, okay, is a circular region where you get r equal to 3, and cylinder x squared plus y squared equal to 9. The projection, okay, you get r equal to 3. Okay, then okay, your dA, you use a cylindrical coordinate where the dA change to r, dr, d theta. So dz, you need the limit for z. Okay, limit for z here, lower limit is actually the lower surface. Lower limit is lower surface with z equal to 1. Upper surface is actually the upper limit, which is z equal to 5 minus x. Okay. Z equal to 1, okay, up to z equal to 5 minus x. X change to r cos theta. Okay, you need the limit of r and limit of theta. Okay, cylinder, okay, x squared plus y squared, so you have r equal to 3, and your cylinder is a full, okay, the projection is a full circle, that's why the theta is, okay, from the positive z-axis, this is actually theta equal to 0. Okay, and it's full circle, that's why theta from 0 up to theta equal to 2 pi. 2 pi. If the cylinder is in the first octant only, mean x positive, y positive, then the theta here, if up to here, theta is up to 0 to pi over 2. However, this is a full cylinder, so the projection is a full circle, that's why theta from, okay, x positive, theta 0, and if rotate it anti-clockwise up to the first quadrant, theta is pi over 2. Okay, if semicircle, theta will be equal to, up to here, theta is pi. If 1, 2, 3, 3 quadrant, theta is, here is 3 pi over 2. 3 pi over 2. Okay. Fourth quadrant, theta equal to 2 pi. So in this case, okay, then limit of r from 0 to 3, limit of theta 0 to 2 pi. Okay, as you integrate in triple integral in Cartesian coordinate, okay, so first of all, we integrate respect to z first. Okay, when integrate respect to z, okay, r and theta are actually constant. So r is constant here. So integrate r respect to z, we have r times z. Okay, plug in the limit of z into z, then plug in into r. So you have 5 minus r cos theta minus 1. 5 minus r cos theta, okay, minus, okay, when you plug in z is 1, so minus substitution of lower limit, which is 1. So 5 minus 1, we have 4 minus r cos theta. Okay, now dr d theta. So now you integrate respect to r, while cos theta or theta is constant. So total here you have 4r. Integrate 4r, so you have 4r squared divided by 2. So it total becomes 2r squared. So integrate, okay, don't forget this is r squared. Integrate minus r squared cos theta. So minus r cubed over 3 cos theta. Plug in theta from 0 to 3. So you plug in the upper limit, okay, to the integrate respect to x, make sure you plug in into x. So 3 squared is 9. 9 times 2, you have 8. So this is a 3 cubed divided by 3. You have left 3 squared, which is 9 cos theta, minus 9 cos theta. Okay, lastly, integrate respect to theta. So you have 18 theta minus, integrate cos theta is a positive sin theta. This will get negative 9 sin theta. Plug in theta from 0 to 2 pi, you get 36 pi. The second example, find the volume of the cylinder x squared plus y squared equal to 4. Okay, again, we have a cylinder, but now r squared equal to 4 or r equal to 2. Okay, you can, okay, r is magnitude, so r, okay, equal to 2, don't take r negative value, because r is magnitude must be positive, minimum is 0. It means r0 is actually r from here, r0. Anything you take here, this is all r. So start from origin, all the r is actually 0 to 2. That's right, okay? No matter which radius that you take, okay, you are taking is always r from 0 to 2. So again, we have cylinder x squared plus y squared equal to 4. Okay, and the cylinder is actually bounded by the plane z equal to 0 and z equal to 4 using cylindrical coordinate. Okay. So the lower surface or lower limit is z equal to 0, upper surface is a flat surface z equal to 4. So this lower limit of z is upper limit of z, and the projection of a cylinder, since the cylinder x squared plus y squared equal to 4 without z variable, the cylinder is parallel with z axis. So we press the cylinder parallel with z axis, you get the projection is on xy plane, which is a full circle with radius 2 centered at origin. So the r from 0 to 2, full circle, so theta from here 0, 1 cycle, so it's 0 to 2 pi. 0 to 2 pi. Okay, the volume, theta 0 to 2 pi, r 0 to 2, okay, z is 0 to 4, because the cylinder is bounded by the plane z equal to 4 up to z equal to 4. Okay, dv in cylindrical coordinate, okay, by maintaining dz, a is actually r dr d theta. Then integrate r respect to z, you have rz, plug in, okay, the limit you get 4r. Integrate 4r respect to r, you have a 4r squared divided by 2 or 2r squared, plug in say r equal to 2. So you have here 4 times 2 is 8. Integrate 1 theta, it's actually you have 8 k times theta, right? Then plug in the theta from 0 to 2 pi, you get 2 pi. So 8 times 2 pi, you have 16 pi. Okay, or you can check the volume of a cylinder is actually given by pi r squared h. The height is actually given by z equal to 0 up to z equal to h. R in this case is 2. So pi r squared times 4, you get also 16 pi. This is using the formula of volume of a cylinder. This is using triple integral in cylindrical coordinates. Okay, the third example, find the volume of the paraboloid z equal to r squared. Okay, remember x squared plus y squared replaced as r squared. So you have the surface z equal to r squared. Okay, so this is a paraboloid. Okay, paraboloid z equal to r squared. Initially, the paraboloid is actually is open unbounded from the minimum point x0, y0, z0. You have the minimum point x0, y0, z0, and it's actually unbounded. To find the volume, you must bound the paraboloid surface, and this surface is bounded by the plane z equal to 4. So means we have a flat horizontal surface z equal to 4. Okay, since the solid is parallel with z axis, again we integrate respect to z first. Integrate respect to z first. Okay, and the lower limit will be the lower surface, which is z equal to r squared, up to the upper surface z equal to 4. Okay, so you have here. So dv is r dz dr d theta. So lower limit is a paraboloid, upper limit is a flat z equal to 4. Okay, to get the projection of r, okay, you have to solve the surface, the paraboloid surface z equal to x squared plus y squared and z equal to 4. Okay, means when you plug in z equal to 4, because the paraboloid intersect with the plane z equal to 4, which needs the circle x squared plus y squared, because z is 4. So x squared plus y squared is 4 of r equal to 2. R equal to 2. Again, this is a full paraboloid. Okay, so we use a full circle, which is R from the R here 0 up to 2. Theta 0 up to 2 pi. Okay, theta 0, okay, up to 2 pi. So R 0 to 2, theta 0 to 2 pi. So again, okay, similar integrations. Integrate R dz here, Rz, plug in the limit, so 4 minus R squared. Later on, integrate respect to R. So integrate 4R, we have 2R squared. Okay, integrate minus R, R squared, so minus R cubed, so minus R power 4 divided by 4. Okay, plug in the limits, okay, upper limit, lower limit, we get 0. So you have here, this is 8 minus 4, or 4. Lastly, okay, you integrate 4 respect to theta from 0 to 2 pi. And this is d theta. Okay, this one will get 2 pi. 2 pi. So the answer total is 4 times 2 pi, which is 8 pi. So we revise back. Okay. If we have volume of a cylinder, x squared plus y squared equal to 4, bounded from z equal to 0 and z equal to 4. So the volume of cylinder, so R 0 to 2, 0 to 2 pi, the cylinder is bounded by the flat surface z equal to 0 up to z equal to 4. Okay, volume of the paraboloid here. So the lower limit of z equal to R squared until z equal to 4. Because we bound the paraboloid by the plane z equal to 4. When you plug in z equal to 4, you get a circle R radius k R equal to 2. Hence k limit of R 0 to 2. 0 to 2 limit of theta 0 to 2 pi. Okay. Limit for z, this is a paraboloid until the flat z equal to 4. Okay, then we have the fourth example. Find the volume of the solid bounded above by paraboloid. Above is paraboloid, below is xy plane. On the side by the cylinder, x squared plus y squared equal to 4. What's that? So it's actually here. Above is paraboloid. Okay, what's the paraboloid that we have? Z equal to x squared plus y squared. So mean this is the upper limit, z equal to r squared. Okay, bottom on xy plane. So mean bottom z equal to 0. So your limit will be z0 until z equal to r squared. Okay, the solid that we are going to find is actually bottom is z equal to 0, top is the paraboloid, side is a cylinder, x squared plus y squared equal to 4, or r equal to 2. So again, limit for r 0 to 2, and this is a full circle, theta from 0 to 2 pi. It's actually okay, the shaded red color volume that we want to find. And or you can find it using the volume of a cylinder. In I think example 2, volume of cylinder from 0 to 4. Okay, subtract with volume of the paraboloid in example 3. Then you can get the volume that we are going to find, which is okay, top is okay, paraboloid, bottom is okay, bottom is z equal to 0. It says that here. Z0, bottom is flat, okay, top surface is a paraboloid, okay, and the intercept at, because side is a cylinder, okay, side is a cylinder, x squared plus y squared equal to 4. It is a paraboloid inside the cylinder, and the intercept at, because when you plug in x squared plus y squared equal to 4, when they intercept at z equal to 4. Z equal to 4. The intercept at z equal to 4. when z equal to 4, the z equal to 4 or x squared plus y squared is 4, r is actually true. R is true. That's why r from 0 to 2, theta from 0 to 2 pi. Again, here you integrate r dz, you get rz. Plug in limit 0 to r squared, so you have r and r squared, which is r cubed. Integrate r cubed respect to r. So r power 4 divided by 4. Plug in the limit 0 to 2. So you have 2 power 4. Okay, divide by 4 is 16 divided by 4, you get 4. Okay, and then integrate 1 d theta, you have theta. Plug in limit from 0 to 2 pi, you have 2 pi. So total we have 8 pi. Okay, as I said, you can check it actually with this volume. Okay, is actually you can take the volume of cylinder. In example 2, 16 pi. Deduct volume of the parabola in example 3, which is 8 pi. Then you get the result 8 pi. Value with what you obtain using cylindrical coordinates. Okay, example 5 now. Okay, finds the volume of a hemisphere z equal to sine 25 minus x squared minus y squared. Hemispheres, okay? Hemisphere, okay. So lower surface we have z equal to 0. Upper surface is z equal to sine 25 minus x squared minus y squared. Become here 25 minus r squared. You want to see it here? It's like here. 25 minus, factor out your negative, and then x squared plus y squared is r squared. So bottom surface is z equal to 0, top surface is z equal to sine 25 minus r squared, because hemisphere z equal to sine 25 minus x squared minus y squared is parallel with z axis. So you integrate with dz first. Lower surface is on xy plane or z equal to 0, or this is a lower limit. Upper surface or upper limit is from the hemisphere equation, which is z equal to sine 25 minus r squared. This is the upper limit. And then to get the projections of your hemisphere, to get projection of hemisphere, you may square it back from here. You square it back. So you have z squared equal to 25 minus x squared minus y squared. To get the projection of region R, which is on z0 or xy plane z0, okay, then this is 0. So 0 equal to 25 minus x squared minus y squared, or x squared plus y squared will be equal to 25, or r equal to 5. And the region R is a full circle, so theta from 0 to 2 pi. Okay, that's why theta 0 to 2 pi, r is 0 to pi, or r is actually the radius of your sphere too. To get the r, from hemisphere you square it and then let z0, then we get the r is 5, full circle, theta 0 to 2 pi. So again, dA is r and dV is r dz dr theta. Integrate r respect to z, we have rz. And then lower limit is 0 to sine 25 minus r squared. So plug in the upper limit, so r times sine 25 minus r squared, plus plug in 0, you have 0. Okay, to integrate this one, to integrate r sine 25 minus r squared, you may use the substitution technique, u equal to 25 minus r squared. Okay, if you want to integrate respect to r, then you find du dr will be minus 2r. And then du will become negative 2r dr. So you notice you have the term r dr, r dr. So for r dr, you replace by, with negative 2 bring to here. So r dr become du divided by negative du minus du over 2. Hence, the integral of sec 25 minus r squared r dr. So r dr replaced by negative du over 2. Okay, remember u is 25 minus r squared. Power is square root is u power half. So integrate u power half. You have u power 3 over 2 in the half here is plus 1. For integration, the power increased by 1. Then divide by the increased power. So u power 3 over 2 divide by 3 over 2. So initially here you have negative half. 2 and 2 here cancel, you have negative 1/3 u power 3 over 2. Okay, replace back u is 25 minus r squared. Okay, power 3 over 2. So you have negative 1/3. Okay, this is a u which is 25 minus r squared power 3 over 2. Okay, and limit, okay, now is we already change u back to in terms of r. Limit of r is from 0 to 5. So when you plug in upper limit, so 25 minus 5 squared, you have 0. Okay. Minus, we have substitution of lower limit, so minus 25 minus, okay, minus 0 squared, which is 25. 25 power 3 over 2 is actually sec 25. Because minus 0, this is nothing. Sec 25 power 3. Or 5 power 3. 5 times 5 times 5, you get negative, okay, 125. So negative, negative, positive, 125 over 3. Integrate 1 d theta from 0 to 2 pi. Here you have 2 pi. So 125 times 2 pi, 2505 over 3. Okay, in case you forgot how to integrate using substitution technique, if limit of r here is constant, you may use your scientific calculator to integrate it. Okay, here. So this is your scientific calculator. Let's see. Here's a calculator. And then of course in your scientific calculator, you have the integral is in the variable x only. So the r here, you change it to x. So I put x as 25 minus alpha, that's not x squared. Okay, so x 25 minus x squared dx. I'm going to integrate the dr. Okay, from 0 to 5. 0 to 5. It will take some time, okay? So you get the answer 125 over 3 here. And then for the integral d theta 0 to 2 pi, you get 2 pi. That's why 2505 over 3. So in exam case, you are allowed to use a scientific calculator. In this step, you can get 125 over 3 here. In this step, you can skip, okay? Because now we are not going to test your integration techniques, but your multiple integral techniques. Okay, example 6, okay? Find the volume of the solid bounded above by hemisphere. Okay, the same hemisphere. Z equal to sec 25 minus x squared minus y squared. Okay, below by xy plane. And on the side by the cylinder, x squared plus y squared equal to 9. Meaning you have a, okay, top is hemisphere, bottom is xy plane, but the side is a cylinder. Okay, like this. Okay, this is a hemisphere, z equal to sud 25 minus x squared, okay? And side is cylinder, x squared plus y squared equal to 3, or r equal x squared plus y squared equal to 9. Okay, this is a cylinder, r equal to 3. Then the solid that we are going to find is a red color that I shaded. Side is a cylinder, r equal to 3. Here. X squared plus y squared equal to 9, or r equal to 3. Then the solid that you are going to find is a cylinder on the xy plane and top covered by the hemisphere. Z equal to sud 25. This one becomes r squared. So the lower limit will be z 0, because on xy plane, upper limit of z is z equals sud 25 minus r squared. And limit for r 0 to 3, because from the cylinder, you get limit for r 0 to 3. Limit for theta, because it's a full circle, theta 0 to 2 pi. 0 to 2 pi. Okay. So theta 0 to 2 pi, r 0 to 3. Okay. The solid is a scale. Bottom is a cylinder on xy plane, that's why z0. Top is covered by your hemisphere, z equal to sud 25 minus r squared. So again, in the dv is r dz dr d theta. So integrate, okay, integrate r respect to z, you have r times z. Remember, integrate respect to z, so you plug in into z variable. So become r sud 25 minus r squared. So similar with, okay, just now example. This is what you integrate just now. Just an example, what you integrate. Yeah. Okay, negative 1 in previous example. Same integral. You get negative 1/3. Okay, 25 minus r squared power 3 over 2. And then now, okay, plug in r from 0 to 3. 0 to 3. Okay, compared to just now, the hemisphere, if compared to the hemisphere, the difference is here. If hemisphere just now r is 0 to 5. But a solid side by cylinder, top by hemisphere, with the same hemisphere, the difference is actually your r 0 to 3. It's only different at r 0 to 3. If just now, okay, volume of a hemisphere, z equal to sud 25 minus r squared. So lower limit, limit for z same, limit for r is 0 to 5. Theta same, because your projection is a full circle. So same integral, and you plug in, okay, you integrate respect to x, so you plug in into x here. Okay, so this is 25. Plug in r equal to 3, so r squared, we have 9. So 25 minus 9, we have 16. Okay, 16 power 3 over 2 is actually square root 16, and then you power 3. So square root 16 is 4 times. 4 power 3, you have 64. Okay, when you plug in r equal to 0, so this will be 0. So this is sud 25, 5. Okay, this one we have sud 25. And then power 3. So this is 5 power 3, we have 125. So you get this is negative 61. And negative will become 61 over 3. Okay, the last integral you have the result 2 pi. So total is 122 pi over 3. Example 7. Find the volume of the remaining solid if a solid bounded above by hemisphere. Again, it's the same hemisphere. Z equal to sud 25 minus x squared minus y squared. below by xy plane and on the side by the cylinder x squared plus y squared equal to 9 is drilled out from the hemisphere z equal to cert 25 minus x squared minus y squared. Okay, is actually, okay, this is what example? Example 7. Example 5, we find the volume of a hemisphere z equal to cert 25 minus r squared. Okay, example 6, we find the volume of a cylinder, but top is a hemisphere. Now, okay, this example is actually, example 7 is actually, it takes the solid that we want to find is actually, we drill out the solid which is side by cylinder, top by sphere. So left is just the outside. So for hemisphere, the projection R is 0 to 5. 0 to 5. Okay, if you find the volume of the solid, top is hemisphere, bottom side is cylinder, then the R from 0 to 3. If you compare these two examples, volume of hemisphere, okay, with z equal to cert 25 minus x squared minus y squared, limit of r 0 to 5, limit of theta, limit of z will be same with this solid. This is the same hemisphere, however the hemisphere, okay, is bounded, okay, means side is a cylinder, r equal to 3, r equal to 3. Hence, the volume, okay, the limit for z and limit for theta are same, only limit from r 0 to 3, because they have a side is cylinder with 3 units. Okay, now we want to find the volume, which is you drill out this volume here. You want to find the remaining volume when you drill out the volume where side is cylinder, top is sphere. So mean it may take the answer from volume of hemisphere deduct volume of side is cylinder, top is hemisphere to get the result for example 6. Remaining solid. Okay, if the solid above is hemisphere, below xy plane on the side by cylinder, drill out, take out, like okay. This one we don't want. What we want is only here. So the bottom surface, because it's on xy plane, z 0. Upper surface, there z equal to cert 25 minus x squared. This why limit for z same. Okay, and the projection for this case, remaining solid is actually a green color. Means is actually outside of the cylinder, but inside your hemisphere. That's why limit for R for this case is 3 to 5. Means okay, if limit for R 0 to 3 is actually you find the volume of the solid, okay, which is this one, cylinder, 0 to 3. 0 to 5, we find the volume of the hemisphere. Okay, so that's why the difference is here only. Limit for z still same because it still have same hemisphere. Limit for theta still same because still full circle. So limit for r now change to 3 to 5. Okay, in example 5, limit for r 0 to 5. Example 6, limit for r is 0 to 3. So with the same integral, you do it, you get 1285 over 3 because everything same, only change by the limit 3 to 5. 3 to 5, you get 128 over 3. Okay, as I said, volume in this example 7 is same with the limit, volume of this example 7 is actually the volume in example 5, which is a hemisphere, deduct volume in example 6, which is, okay, top is hemisphere, bottom is z equal to 0, side is a cylinder. So this is what we obtain in example 5, 250 over pi over 3. Example 6 here, you deduct, which is actually tally to 1280 pi over 3, which is solved using triple integral in cylindrical coordinates. We can compare example 5, 6, they are just different at the limit of the arc. Example 5, hemisphere, okay, limit r 0 to 5. This one, example 6, is hemisphere, on top side is cylinder, r equal to 3, that's why limit of r is 0 to 3. And this example is actually dig out this volume from the hemisphere. Okay. That's why the r change 3 to 5, limit for z same, limit for theta same. Okay. Example 8. Use cylindrical coordinate to find the volume of the solid bounded above by a sphere x squared plus y squared plus z squared equal to 16 and below by cone z equal to third x squared plus y squared. Okay, so this is what we want. Bottom is cone, top is a sphere. Okay, your cone is z equal to third x squared plus y squared, or z equal to third r. Okay. Above by sphere. Okay, sphere is actually this one. This is a full sphere, but the cone here, z equal to third, okay, r is actually start from the minimum point x 0, y 0, z is 0 here. That's why the bottom surface is actually z equal to third r. Upper surface, because cylinder, sphere, you have the x squared. Put it here, easy. Yeah, x squared plus y squared plus z squared equal to 16. But when we take the upper surface only, upper surface, that's why you make the z as a title. Z is a positive, okay? Positive z is actually the upper hemisphere. Okay, if you take negative, third 16 minus x squared minus y squared will be the bottom here. Here, okay, this is a z, bottom surface z equal negative third 16 minus r squared. Means if you cut your sphere horizontally on the xy plane, okay, you have the upper surface is what we call upper hemisphere. Okay, upper hemisphere, from your sphere equation, okay, take z as a title, we have a positive, negative, third 16 minus x squared minus y squared. Positive third is the upper hemisphere equation, negative third is a lower hemisphere equation. Since this is a cone, okay, bottom is given by, you want to find the solid, okay, below by cone, top by the sphere or the upper hemisphere. Then this is the upper limit, your lower limit is a cone, z equal to third r. Z equals third r, means the cone. Lower limit is a cone, upper limit is the upper hemisphere. dv r dz dr d theta. To find the projections of the cone, where the top surface is a hemisphere, you have to solve, okay, the equation of your sphere and cone. Mean their intercept at which circle. So this is a sphere equation, x squared plus y squared plus z squared equal to 16. And this is a cone equation. You solve this equation, these two equations simultaneously. When you square this one, okay, so you have, okay, when you square the cone equation, this is actually the upper cone equation. When you square it, you have actually the double cone. Means you have a, okay, bottom and the top cone. Z squared is actually x squared plus y squared. Okay, so means that this is actually x squared plus y squared here is equal to z squared. So z squared plus z squared equal to 16, or 2z squared equal to 16, or z squared equal to 8, then z equal to 38. Then substitute z equal to 38 in the sphere equations. So 38, when you square, it will become, okay, 8. So 8, you square it, so lastly you get x squared plus y squared, 8 this side, 16 minus 8, so you have the x squared plus y squared equal to 8, or r equal to 38. Okay. Your projection of the sphere is actually with r, mean this one give a bigger circle, r equal to 4, r equal to 4. And okay, this circle is actually, when you solve sphere and the cone equation simultaneously, you get is actually r equal to 38. And region R is full circle, so theta from 0 to 2 pi. So theta 0 to 2 pi, r from 0 to 38. To get the r, you have to solve the simultaneously the intersection of the cone and the sphere. So you get r equal to 38. So integrate r dz, we have rz. Plug in the limit for z here. So r times 60 minus r squared, and here, so minus r times r minus r squared. Okay, integrate respect to r. Again, this one you can either use your calculator or you can use a substitution techniques. Okay, as I shown in the previous example. Then you get this one. Okay, integrate r sub 60 minus r squared will be negative 1/3 16 minus r squared power 3 over 2, and then integrate negative r squared, negative r cubed over 3. So this is back down negative 1/3, so this will be positive. So this negative r cubed over 3. Okay, plug in the limit, and integrate respect to theta later on. Okay, finally, this is the answer. Okay, lastly, the last example use cylindrical coordinate to evaluate the triple integral in Cartesian coordinates. Okay, so notice this is integrate respect to z, respect to z. Okay, so limit of z from 0 to 9 minus x squared minus y squared. This is actually a paraboloid. Paraboloid with maximum point z equal to 9. Paraboloid. Okay, and for limit, we don't integrate respect to y. So this is a limit for y. From negative third 9 minus x squared up to positive third 9 minus x squared. And limit of x tells that x from negative 3 to positive 3. Okay. Y equal to third 9 minus x squared is actually the upper curve here. Mean this upper curve here is actually this one. Y equal to third 9 minus x squared. So the bottom curve, which is y equal to negative third 9 minus x squared. Okay, this is the bottom curve. And the bottom curve here, bottom curve given by here. Okay, or you square this one, or you square y equal to positive negative third 9 minus x squared, you will get x squared plus y squared equal to 9. which give r equal to 3. R from 0 to 3 here. Okay, limit for x tell you x from negative 3 up to positive 3. Hence, this is a full circle. If they give you, let's say, limit of x from 0 to 3, hence your area is only in first quadrant, then theta 0 to pi over 2. So since here x, okay, the y from the bottom curve, okay, your y, the bottom curve, the y is given by y equal negative sine 9 minus x squared. The top curve, y equal to sine 9 minus x squared. And if you have a bottom curve, upper curve, you use dy dx and sums your vertical bar from left, which is x equal negative 3 to positive 3. Okay, this is what the limit held about here. X negative 3 to positive 3 dy. Okay, the bottom curve is actually, okay, the bottom, okay, semicircle circular curve. This is the upper circular curve. And when you square back, okay, y equal to positive negative sine 9 minus x squared, you get x squared plus y squared equal to 9. You get r equal to 3. So from here we know that limit for r is 0 to 3, and this is a full circle, so theta from 0 to 2 pi. Okay, and from the paraboloid, we know that z 0 to, okay, so this becomes 0 to 9 minus r squared. Hence, okay, and the integrand is x squared, so x change to r cos theta. So x squared is r squared cos squared theta. So dz dy dx, okay, maintain the dz dy dx using polar coordinate is r dr d theta. Polar coordinate in 3D, it becomes cylindrical coordinate. So 0 to 9 minus r squared. Okay, from dy, when you square, you get the r equal to 3. And for limit for x, tell you this full circle, that's why theta from 0 to 2 pi. Okay, now we already convert from Cartesian coordinate to cylindrical coordinate. Now we integrate respect to z, where r and theta are constant. That's why r squared times r, total you have r cubed, so cos squared theta. Okay, this is all are constant. So integrate constant respect to z, you have constant times z. Plug in limit for z from 0 to 9 minus r squared. So you have here, after plug in upper limit, lower limit minus 0. Then secondly, we are going to integrate respect to r. Okay, put it here. So total you have 9, okay, expand in here. Total you have 9r cubed minus r power 5. Okay, integrate respect to r first, where theta is constant. So you have 9r power 4 divided by 4 minus r power 6 divided by 6. Plug in the lower limit and upper limit of the r. Okay, simplify it, you have here 729 over 12. And then integrate cos squared theta d theta from 0 to 2 pi. Okay, you can change your cos squared theta to half of 1 plus cos 2 theta. So 2 times 12, so 729 over 24. Integrate 1, respect to theta, you have theta. Integrate cos 2 theta, get positive sin 2 theta over 2. Plug in theta from 0 to 2 pi. That here 2 pi sin 2 times 2 pi sin 4 pi is 0. When you plug in 0, so this 0, sin 0 also 0, that's why it's only have 2 pi. So total the answer, okay, and here cancel 729 over 12. Okay, in case you don't know how to change cos squared theta to half of 1 plus cos theta, okay, you can also use your scientific calculator to integrate it. To integrate this one, and you should get the answer is actually 5 over 12. Let's see. Open back the scientific calculator. Let's see, it integrates the cos squared. Cos of x. Okay, I squared it 0 to 2 pi. 0 to 2 should has a pi. Okay, this is the answer. And okay, we won't get exactly here, but you get fraction point, doesn't matter. This is the answer for cos, okay, integral of cos squared theta from 0 to 2 pi given by the calculator. And then if you multiply by 729 divide 12, you get answer 380.177. The answer that 380.1770. Okay, we check it. The answer given in the pi form. 729.5 divided by 12. What's the difference? Check it with the answer. Oh, I think maybe let me check whether it's in radian. Yeah, this is, you get this is pi. Okay, sorry, just now the answer was in degree form. So the integral of here cos squared theta d theta 0 to 2, okay, 0 to pi, 0 to 2 pi is actually you have pi. Yeah? So lastly, you have to multiply by 729 over 12. That's why you got 729 pi over 12. Okay, sorry, just now because I should set the angle in radian units. Because mean from calculator, in scientific calculator, this part straight away I get the answer is pi. So 729 pi over 12. But here is we calculate manually. You can see. Integrate cos squared theta, the theta from 0 to 2 pi. By calculator, you get the answer pi. So 729 pi over 12. Okay, with this, thank you for your attention, and watching this video.